Hello everybody, this is Mr. Molikash. This is a week 10 video from Math 172. As always, want to remind you that this is my email address, and if you're watching this video and you have any questions, feel free to shoot me an email. This week's video is about the law of cosines. And there's two ways to write this equation. And there's a lot of information that goes into where this equation comes from. But the law of cosines, it looks a lot like the Pythagorean theorem at first. So let's say that we have a triangle that has three sides. And we call these sides, sorry, a piece of hair or something in this piece of paper. We call these sides A, B, and C. And so this would be angle C, this would be angle B, and this would be angle A. The law of cosines says that in any triangle, regardless of the size of the angles, that c squared equals a squared plus b squared minus 2ab times the cosine of angle C. So at first glance, when you see this, you might be thinking that this looks a lot like the Pythagorean theorem. And if this angle C were a 90-degree angle, that's exactly what it would be. It would be the equation that comes from the Pythagorean theorem. And the reason for that is that the cosine of 90 degrees is 0 from the unit circle. So in the case where 90 degrees is used, the cosine of 90 degrees is 0, and 0 times anything is 0, so you just get this, right? So if we were to straighten that angle out and make it, maybe this is a leaning, wall or something. If we were to straighten that wall out and had a right triangle, then we'd have a hypotenuse for C and the legs be A and B. And we'd be using this equation, but this is for more general use, okay? And a couple of things I want to tell you about this equation. One is the first letter and the last letter always match when you write it like this, always. So you can write this differently. You can say b squared equals something that ends up with a b, right? Well, if these letters are B and B, notice that all the other letters are different from the ends, right? So if we're using B, then the other one should be A and C. And then the cosine of angle B. And another thing, again, the first and last letters match, or you can do A squared equals B squared plus C squared minus 2BC times the cosine of A. So that's one thing you should notice about the law of cosines, okay? One other thing you should notice is that there are three terms on the right side of this equation, and this is, as big as it is, this is one term. Okay, so is this, and so is this. So this is a term, and this whole thing is a term. And the reason I say that is because what you don't want to do is try to add this together. Never, 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 never add that together, because this is only part of a term, and you can only add terms together, right? All this stuff is multiplied. Okay, we'll see that, we'll mention that again when we do an example. Okay, so the lowercase letters, of course, are sides, and the uppercase ones are angles. So you would use this version of the formula if you were given side angle side. If you were given side angle side. So we'll do an example of that in a moment. Okay, another way to write this is if, let's say that you know all three sides and you want to find out an angle, right? So you can rewrite this where the cosine of C is all by itself, right? And if you do that, there's a lot of work that has to be done to that. First of all, you take this to the other side and make it positive. You take this to the other side and make it negative, and you divide, right? So I'm going to show you what that looks like without actually doing all the math. Okay, so this is a squared plus b squared minus c squared divided by 2ab. Again, it's important to see that the first letter and the last letter match. First letter and the last letter match. So another way I could write this is the cosine of b is equal to a squared plus c squared minus b squared all over 2ac. Or the cosine of a is b squared plus c squared minus a squared over 2bc. Yeah, this looks really confusing, so I would definitely write all this down and make some good use of it, or just kind of have this video paused at this stage. So why would you use these formulas as opposed to these up here? I mean, this first one is exactly the same thing as this one. It's just kind of solved for the cosine of c. So the reason you would do this is to find an angle. You'd put all three of your sides here, a, b, and c, and then you put a and b here. And when you get this number, you do the inverse cosine of it, and you're going to get an angle. So this is used when you have all three sides and you want to find an angle. Okay, so let's go right into some examples. So, first example. Let's say solve triangle ABC if a equals 3, b equals 5, and angle C is 120 degrees. So there's the problem. First thing I would do is to try to draw a picture, right? So being that angle C is an obtuse angle, it makes sense to draw an obtuse angle, right? Something like this. So this would be angle C, and this would be side C. Sorry about my terrible handwriting or artwork. This appears to be the shorter side, so I'm going to call that A and this angle A, and this B and that angle B. Okay, and it says that A is 3 and B is 5. So you can see that this is the side angle side variety, and being that I have angle C and I'm having to solve for solve the rest of the information in this triangle, being that I have angle C, I'm going to use this first line. Okay, so I have side angle side, and I'm going to use this first line. So let me go ahead and write that down for you again. We're going to say that C squared equals A squared plus B squared minus 2AB cosine angle C. So let's plug in what we know. We don't know C, but we're going to find out in a few minutes, or a few seconds even. So 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine of 120 degrees. Now, like I did in last week's video, you could type all this out in your calculator. Just make sure that your calculator is in degree mode. Okay, so I'm going to do that off screen real quick. I'm going to type in, actually I'm just going to use my I didn't know if you know that you could do this, but I'm going to use my web browser. You can type this in Google's web browser up in the URL address bar, and as you're typing it out, it will tell you the answer. Now, just a word to the wise, if you do this, write DEG for the degree symbol. Otherwise, Google will think that's 120 radians. Okay, so this whole thing turns out to be 49. Now, I will say normally this doesn't turn out to be a whole number. You know, the cosine of a number is probably decimal or some kind of weird radical, so you get some crazy number. So again, feel free to type all of this out in your calculator, but you should get 49 if you do it right. So if you're doing it piece by piece, again, let me remind you not to do 9 plus 25 minus 30 all together and then attach that to the cosine of 120, because this is one term, this is one term, and all that other stuff is another term. Okay, so very important that you type this whole thing out correctly. So of course C is 7, right? All right, so there's one piece of the puzzle, right? Now that we have all three sides, we can find another angle. Now, it's important, what I'm about to say is very, very important, okay? If your given angle is obtuse, and only if it is obtuse, then it is safe to use the law of sines to find either angle A or angle B. The reason for that is because, remember, the law of sines has this ambiguous case where one triangle may have an acute angle and the other one's obtuse, right? So the good news about this triangle is that since I already have an obtuse angle, it's impossible to have another obtuse angle. Otherwise, I'd have more than 180 degrees. So if this is obtuse, you can use the law of sines. And that's easier than what we did here, okay? So I'm going to do that, but I will tell you that if this is not obtuse, and especially if this is not the biggest angle, okay, if this turns out to be the biggest angle, let's say it's 80 degrees, then you're still safe to do the law of sines, even if it's not obtuse. But if it's not the biggest angle, like if you had angle A here and side A, then it'd be dangerous to use the law of sines because you might get an acute angle in your calculator when in actuality the right answer is an obtuse angle. So the safe way to do this in all situations is to do the law of cosines again, and I'll do that in a later example, okay? I'll show you how to use the law of cosines to find an angle. In fact, it's these three formulas down here that you would use. So we'll do that in another example. But for now, I'm going to do the law of sines, and I'm going to try to find angle A. So I'm going to say 3 over sine A is the other two that I have that match, 7 over sine 120. So I'm going to cross multiply. And divide by 7. Don't divide by sin, that's a sin. Don't do that. What we want to do is the inverse sine of this, all right? So what we need to do is put all this in our calculator and then hit second sine to find the measure of the angle, right? All right, so I'm going to type that all out in my calculator. 3 sine 120 degrees divided by 7. Okay, so on my calculator screen, which you can't see, I get 0.3711 and a bunch of other stuff, right? This is probably what your calculator says. So A, the value of A, is the inverse sine. And again, I'm trying to find angle A here, right? This is a capital A, not a lowercase. The inverse sine of all this. Now, no need to type all these numbers out again in your calculator. Since you have this on your calculator, just hit second sine, right? So I'm going to do that. Sorry, my internet's a little bit slow right now. All right, so this turns out to be 21.79 degrees. And that's really good news because now I can just subtract these two from 180 to find angle B, right? So angle B is 180 minus angle C minus angle A, right? So I can do that in my calculator too. 180 minus 120, which of course is 60, minus 21.79. 21.79, sorry, okay. So that's 38.21 degrees, and there we go. We've solved the triangle. And remember, like I said last week, it always is a good idea to make sure that your longest side is opposite from the biggest angle and the smallest side is opposite from the smallest angle. So looks like everything checks out. Okay, another example is when we have all three sides. So, whoops. Let's say that we have all three sides at sides A, B, and C. So example 2. Solve triangle ABC if A is 6, B is 7, and C is 10. Let's do that. So we'll try to draw a triangle, and it doesn't matter if it's drawn to scale or whatever. maybe that's 10, that's 6, and that's 7. So this would be A, this is B, this is C, so this is capital C up here, this is capital B there, and this is capital A here. And this is the side triangle that I was telling you about earlier, right? So, I don't have any angles. Ruh-roh. No fear. I definitely can't do the law of sines because I'd have 7 over the sine of I don't know equals 6 over the sine of I don't know equals 10 over the sine of I don't know, and there's too many I don't knows, right? So what you do is you just pick an angle to find, and I'm going to pick the biggest one, like I said earlier. If I pick the biggest one, then I'm good to go to use the law of sines. But in the event you have to use the law of cosines to get an angle, this is what you do, right? I'm going to use this one right here. And again, it's important to find the largest angle first. And the reason you want to do that is so that later on, if you have the biggest angle out of the way, there's no more possibilities for obtuse angles. You can use the law of sines. Okay, so I'm going to do this formula that helps me find angle C because I know that's the largest angle because it's opposite from the longest side. Okay, so let me write down that formula for your reference one more time. Okay, so we're going to say the cosine of C is equal to 6 squared plus 7 squared minus 10 squared over 2 times 6 times 7. Let's see, that's 36 plus 49. Let me get into my calculator here so I don't have to do all this math in my head. 36 plus 49 minus 100. So that's negative 15 over, looks like 84. And that might even reduce, actually. See, that's 12, 3 times. Yeah. So if you divide this by 3, you get 28. And if you divide this by 3, you get 5, right? All right, so C then is going to be the inverse cosine of negative 5 over 28. So I got to go figure out what that is. And again, I'm using my calculator off screen. Sorry about that. Okay, so the value of C, and this is definitely an obtuse angle because remember that in the unit circle, if the cosine of an angle is negative, then you're going to have an obtuse angle. If it's positive, you'll have an acute angle, which is the reason why the law of cosines has no ambiguous case. Isn't that wonderful? All right, so this is about 100.3 degrees. Definitely our biggest angle, right? Okay, so there's angle C. Now we're going to pick either angle A or B, and we can use the law of sines now to do this because there's no obtuse angles. And remember, inverse sine only gives you an acute angle. So we want to avoid the ambiguous case at all costs. And we've done that by finding the largest angle first. So I'm going to find angle A. So let's see, 6 over sine A equals 10 over sine 100.3 degrees. So I got to do some math here. This is a review of what we did last week with the law of sines. See, 6 and that reduces. So now I have to type out all this junk in my calculator, right? So I gotta do 3 sine 100.3 degrees divided by 5. Okay, and my calculator says that this is 0.590 blah 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 blah. More numbers, right? Okay, so the value of A is the inverse sine of that number sitting in my calculator, right? Sorry, my eye is itching real quick. All right, so this turns out to be 36.2 degrees, 1/8, right? And of course, it's easy to find the third one, right? Just subtract from 180. So I'm going to do that off screen. 180 minus 100.3 minus 36.2 is 43.5. So now we've got all three sides and all three angles, okay? And we, again, just as a check, just to make sure, longest side, biggest angle, shortest side, smallest angle. So we're really happy that we got this one right. So that's how to deal with the law of cosines. I just kind of want to reiterate, if, again, in the previous example, if you are working with a small angle in the side angle side case, okay, you can't do this. Instead, to find this second angle, you'll use one of these to be safe, okay? The only reason you can ever do this is if the first angle that you have is the largest angle in the triangle. I knew that because this was obtuse. And certainly I knew that here because I forced it to be the largest angle because I picked the longest side to work with there, right? So if you do this first, then you're good to go to use the law of sines. And you can see that that is a lot less work than all of this stuff. So hopefully that's been a good help to you. Please reach out to me by email. If you're one of my students, you can leave me a message in the discussion board. And I hope you have a great week.